Hi AP Physics, Nicole here again, and I'll be teaching you how to do, yet again, another AP problem. So you want to look at the 2009 AP Physics B free response questions, and now we're looking at question 4. You'll see that there is a container which holds a water vapor and there's a piston on top of it. The question reads, the cylinder represented in the above contains 2.2 kilograms of water vapor initially at a volume of 2 meters cubed and an absolute pressure of 3 times 10 to the 5th pascals. The state is represented by point A in the PV diagram below. The molar mass of water is 18 grams, and the water vapor can be treated as an ideal gas. So, now that we've highlighted everything in the question, let's see what part A asks us to do. And if you move down, you will see that there is a graph. So, part A asks us to calculate the temperature of the water vapor at point A. So let's zoom in onto the graph and see what point A looks like. Okay, so point A is over here, where there is a volume of 2 meters cubed and a pressure of 3 times 10 to the 5th pascals. So, in order to calculate the temperature of the water vapor at part A, we are going to use the formula PV equals nRT. So let's find some room on our paper. I'll do it right next to it. Okay, so we have the formula PV equals nRT. Now, we're going to manipulate this to find the temperature. So in that case, we get T equals PV over nR. So now we can start to substitute in the variables that they already gave us. T equals the pressure, which they gave us as 3 times 10 to the 5th pascals, times the volume, which they also give us, 2 meters cubed, times N. Now, N is the number of moles, so we have to find what the number of moles is. So, we're going to do N equals 2.2 kilograms, because that's what they gave us, so it's 2.2 kilograms of water vapor, over 18 times 10 to the negative third kilograms per mole. Okay? And then when you solve that, you get that N equals 122.2 moles. Okay? So now that we solved for N, we can substitute that back into our original equation. 122.2 moles times R, which is the constant, of 8.31 joules per mole Kelvin. And then once you plug that into your calculator and get your answer, it should come out to 590.85 Kelvin. Now, when you're doing these thermodynamics questions, make sure that your temperatures are all in Kelvin and not in Celsius. So now, part B says, the absolute pressure of the water vapor is increased at a constant volume So it's increased at a constant volume until it reaches 4 times 10 to the 5th pascals at point B. And then the volume of the water vapor is increased again at a constant pressure to 2.5 meters cubed at point C, as shown in the PV diagram above. Part B asks us to calculate the temperature of the water vapor at part C. So let's go back to our graph, and we see part C. We need to calculate the temperature. So ideally, it's going to be the same formula as part A. So let's go over here and use this blank space. So part B. We're going to use the same formula, we already manipulated it, as T equals PV over NR. Then we get T equals the pressure, which they gave us as 4 times 10 to the 5th Pascal, times the volume, which they also gave us, 2.5 meters cubed, over the number of moles, which we already calculated to be 122.2 moles, times R, which is again just the constant, 8.31 joules per mole Kelvin. And once you plug that into your calculator, you should get 984.75 Kelvin. Okay? Easy as that. Part C asks us, does the internal energy of the water vapor for the process A to B to C increase, decrease, or remain the same? So, we are going to check off the box that says increase. Now, the change in internal energy is going to increase because we are going to look at the graph. If you think about the formula, delta U equals Q plus W, the internal energy is directly proportional to temperature, so they both increase. As the temperature increases, the change in internal energy is going to also increase. So this graph is not cyclic, so that means that nothing remains the same and there's always going to be a change. So we can write that because delta T increases, delta U also increases because they are directly proportional. Okay? So then, if we move on finally to part D, part D asks us to calculate the work done on the water vapor for the process A to B to C. So now we know that on a graph like this, the work is equal to the area below the graph. So, another formula for that is work equals negative P times delta V. So then if we plug in what we know, W equals negative P they gave us as 4 times 10 to the 5th Pascal times the change in volume. Now, the initial volume was 2 meters cubed, and then it increased to 2.5 meters cubed. So when you subtract 2 from 2.5, you're going to get 0.5 meters cubed. And then, again, plug that into your calculator, and you should get that work equals negative 200,000 joules. And then that's your answer for part D. Okay, so this question was relatively simple. Again, it was the 2009 AP Physics B question number 4. If you have any more questions, feel free to ask me. Thanks for watching.